Okay, cool. So yeah, thanks again, everyone, for joining. You're all very welcome. Two really great talks lined up today from Tristan and Cesar. So Tristan is going to be talking about a functional approach to exception handling, which I'm really looking forward to. So Tristan and myself, we're having a conversation, and Tristan sent a message to share this library that he'd been working on. And we've since adopted it in a couple of teams in Toast. It's really nice library. So thanks very much for that, Tristan. And yeah, really looking forward to hearing more about it. And yeah, one of the teams in Boston that are using it did request that we record this, so they're looking forward to hearing about it also. And next up, then we have Cesar, who's a senior software engineer in Toast. So really great to have Cesar on the team in Toast, and they're passionate Kotliner. So Cesar's going to be talking about how to write Kotlin compiler plugins, which is another really new interesting topic, and some really cool use cases there. And the final thing, so I guess we're always looking for speakers. If there's any kind of interesting project with Kotlin you've been working on, or a library in the Kotlin ecosystem, or I guess anything at all in the Kotlin ecosystem. It doesn't need to be language features. It can be kind of anything at all, a database that you're using with Kotlin, or messaging that's made easier with Kotlin, or anything at all. We'd love to hear about it, and yeah, give you any help that is useful for you to help prepare a talk. So with that, I will hand over to Tristan.
Cool. Thank you, Tom. And thanks very much for organizing this. Just before I start, is my screen still sharing? I don't see the border around it anymore, do I?
Yeah, we can still see it.
Oh, cool. Okay, then. Well, let's kick it off. So welcome, everybody, to my talk on a functional approach to exception handling. And let me just make sure this is working. Okay, yeah. So who am I? Well, I'm Tristan Hamilton. I'm an Android developer at Workday. I work out of the Dublin office. Here is a picture of me with one of my cats, Tofu. My hair has kind of shifted around a little since then. I gave an internal version of this talk at the company, and we were to sort of describe ourselves in emoji format. So here's a few things about me. I'm an avid modular synth, I guess, player, but more collector at this rate. My favorite food is burritos, and if you haven't gleaned from the title of the talk, I have a large interest in, or keen interest in, functional programming. So as Tom alluded to, what I'm here to kind of talk to you about is a library that I've been contributing to in my free time called Kotlin Result. It is, well, let's just take a screenshot from the GitHub itself, or GitHub repo. Basically, it's a result monad for modeling success or failure operations, and has a bunch of tags here. So you might be going, okay, what the hell is this? Well, hopefully by the end of this talk, you'll understand first what it is, and also why I think it's worth using. So to start, kind of just want to say, well, why result type? Yeah, if you haven't gleaned, it's a way to it's a great way to handle exceptions. I also think it might be once you understand it, you might realize it could be a cool way to sort of think about how you solve other problems. But largely, I think reasoning about how we handle exceptions is something that we all do in our code every day. So I think it's like a nice tangible thing to start to introduce you into the world of functional programming. And another reason I want to give this talk is to try and sort of pull back the curtains on functional programming in general, which I think for a lot of people is filled with sort of scary jargon and seems quite unapproachable, I think. So you might want me to just immediately show you some Kotlin Result goodness. But I think before we do that, I want to try to break down what some of this jargon is, and hopefully explain it with you without going into too much jargon, and just giving nice simple code examples. And I think to do that, we need to kind of go back right to the beginning to one of the sort of core tenets of functional programming, which is this concept of referential transparency. So what is referential transparency, or we can just call it RT for short? I think the best way to describe that is maybe with a simple function. So say we have this function add3, quite simple, takes an integer and should give us back that integer with 3 added to it. Well, here you can see that if we were to assign a value x to that function, we can very easily replace our add3 with the 3 integer with just the value 6, and we've changed nothing about the execution of the program, or the behavior of the program, should I say. And that's basically what referential transparency means, is that you can replace a function with its returning value and not change the program's behavior whatsoever. So why should you care about that though? Well, I think the first amazing thing about that is nothing's hidden. If you know that a function is referentially transparent, well, then your type signature tells you everything you need to know, which I think is a big help. And secondly, it should make things easier to test, right? So unit testing should be a lot easier if you know that you can always guarantee that the input to the function is always just going to give you the same output and with no side effects. So with that in mind, what happens though if we wanted to change our add3 function to say it only takes positive integers, and that if it wasn't a positive integer, we're going to throw this custom negative number exception we have? Well, does this still uphold referential transparency? Well, now if we try to say give a negative number into our function, can we replace that with just its return value? No, because we've basically halted execution by throwing this exception. We can't replace this with the value with the exception. It's being thrown. And this is kind of the first riddle that working with code that throws exceptions throws at us, right? And we have to kind of wonder, well, is there a way to get around this? And perhaps there is a solution hidden in Jim Carrey's disturbing Riddler costume here, which is the question mark, which you probably all know as Kotlin's null safety. So what we could do here is with our Meetup add3 function here, rather than throw an exception for negative numbers, maybe we just return null instead. So we'll change this type to now have a nullable int, and suddenly we uphold referential transparency. In our negative input case, suddenly now we could just replace that function with the value null, and in our positive case, it still upholds referential transparency. We can replace it with the 6. So great. What have we kind of learned now? Well, nullable types support referential transparency. Throws, it's something that isn't checked by the Kotlin compiler. Obviously, with the throws annotation, and if you've got Java interop, there's some amount that can be checked there. We now know that throwing is going to break referential transparency, right? And just to sort of reiterate why nullables then I guess are good is it supports referential transparency. The type signature tells us everything we need to know, and it should be easier to test, right? These are the things that referential transparency bring us. So hope you're not already feeling like this guy and there's too much jargon. I think for a lot of people, it's easier to wrap their head around these things if we see it in like the context of some real code. So for that, I'm actually going to use a function from our real Android production code base. When I gave this talk internally, I went rummaging around to see could I find some examples where this sort of stuff was happening. So we have this class, new organization info extractor. We're just going to focus on one function inside of that, which is get validated new organization info. Takes the URI, and as you can see, it might give us back the new organization info that we want. Looking inside that function, this is sort of just a snippet of what's important from it to take, which is that we try to get a host out of the URI we've passed in using this web address validator class. And as you can see, the web address validator, when we try to get that valid web address, it can throw this invalid web address exception. And when that happens, we display a toast error message and we return null. So you can see here we're wrapping the exception and returning null. So if we were to think about, is this referentially transparent when we call this function? If we passed it a bad URI, well, what if we tried to replace my new org info, the assignment of that with just its output value? Well, it looks like we could just replace that with null. So I guess we've achieved referential transparency with this function, or have we? You might recall when we looked at the innards of that function that we were presenting a toast when we caught the exception. And as we learned, referential transparency is when we can replace a function call with its return value without changing the behavior of the program. So in that case, we have changed the behavior. We're no longer getting this toast message. So no, our function is not pure. What's a pure function? Well, FP purists will say it's pretty much the only way to write functional code, I guess, in that you don't want any mutable state, and that side effecting actions are going to break your break referential transparency for that function. I'm here to say that, you know, I am not Gollum holding the proverbial, you know, one ring to rule them all FP, thinking that that's the only way to go. I hope you don't glean that from this this talk. I think that is why languages like Scala exist, which was to, you know, bridge the OO and FP world. And I think that, you know, there are times where referential transparency and trying to make things pure make a lot of sense. But of course, having mutable state can be very beneficial and make things a lot easier. So, but with that all said, is null safety always the answer? Is there something more that we can do? What if we want to know exactly why this get validated new organization info failed rather than just getting back null? I think there is a better way. I wouldn't be giving this talk if I didn't. So yeah, let's look back at our call again. We know that right now this isn't referentially transparent, but what if there was a way we could make this referentially transparent and know why this bad URI was to fail? So first off, if we wanted to do that, we would need to no longer make this a nullable type, right? So we can get rid of that. Next thing, inside of our code we were looking at, well, we know straight off the bat that we can't be showing a toast message anymore, right? So that's going to need to go. Next, we're not going to return null. We're actually just going to rethrow that exception. Now, the thing is, when I went and looked inside of get valid web address, it turns out that this invalid web address exception is a custom exception that we're just wrapping multiple things that can go wrong with our web address validator. So rather than that, let's just assume that our web address validator is no longer throwing that custom exception, and it's all the real exceptions that we care about. So we can kind of get rid of that whole thing and now just say, we try to assign the host, and the thrown exception just gets propagated up to the next layer. So now that we've done that, well, have we achieved referential transparency? I don't think so. All we've done is propagate the throwing to this layer, right? And as we've seen, throwing exception is just going to stop the execution of our program. It's not going to just change the behavior. So what if we need to think about this more? The real problem here is that we still don't know how to represent what is being returned as a single type. So I think a good way to start is let's like annotate the value we're looking for here, which is new org info. So right now, all we know is that new organization info seemingly just returns a new organization info type. And we don't know that there's nothing telling us here that, oh, it can actually throw anything. So it would be great if we could do something like this, where now we're kind of saying, well, we know that it can either return this info or it can return an exception. This is something which is called union types. Some languages have it, TypeScript has it, but compiler says no in Kotlin. We can't represent how this is returned here in Kotlin. So we need to think of some other way we can do that. And I guess now that we see, we definitely need to be able to show both types in our return type, right? So something that would actually compile is that, and is valid Kotlin code, is that we could represent our possible new organization info and our possible exception inside of a pair, right, and make them nullable. But of course, this isn't going to be very useful. When we have a pair type, it's quite a generic thing. We're going to need to write a lot of code just to be able to access these things inside of it. But it does help us see that, okay, we're certainly on the right track towards, we need some kind of wrapping container type. We also know that we're going to need to have some kind of success path and a failure path encoded into this wrapper type. And it would also be nice that whatever this type does, we know we want to be able to operate over it. So it would be great if New Info had a way to extract what was contained in the type. And for our referential transparency's sake, we know we want to be able to just replace the function call with whatever is the output is. So it'd be great if we could just instantiate either the success path here or the failure path. So given all this knowledge we now have, I wonder, could we make a more specific version of this wrapper we've constructed that sort of encodes all of this into a nice, pretty type? And I think we can do that. And that is with a type called result. So let's try and write our own version of result here. And we can do it as an algebraic data type, ADT, in Kotlin. So we're going to use a sealed class. We're going to call it result and have a success value v or some kind of error that extends from exception. So we can define our success and failure data classes. And as you can see, for success, it's going to extend result where the exception type is nothing. And with failure, we're going to say that the success type will be nothing. There's one thing we're missing here, which is going to help with with the Kotlin compiler, so that when we actually write this, it'll figure out the types that we want. So we're going to set the value and exception to covariant. That's just a side note here, but this is pretty much going to encode our result type that we want. So if we were to I don't know what happened there. Yeah, sorry. So with that now defined, let's see if we can replace our new organization info with this result type that we've just come up with. So let's replace the return type now with a result of either the info or an exception. And don't know what's going on with my keypad. Okay, yeah. And then what we're going to do is, with our original web address validator function, we can now have that. We'll bring back the try catch, because obviously our web address validator can throw these different exceptions, but instead of the invalid web address exception, now we're just going to catch whatever exception it throws, and we can return back the failure case of our result. And now with that done, let's see, can we now, is this now supporting referential transparency? Well, yes, it looks like it is. So in this specific bad URI case, we can say that we could replace that with a failure result type that contains that it turns out that bad URI had a syntax exception in it. So great, we have managed to achieve referential transparency for our get validated new organization info type, and we've gotten rid of it throwing exceptions. So, but is that everything? I think we recall that in the original version of this function, we would show a toast, right? So we're going to need some way to operate now on our result type. So we could define a side effecting function that takes a lambda for the on failure case. So it just checks if that result is of case failure. And here now we can present our toast. And of course, we could also define an on success side effecting function that we could do whatever we want with the happy path as well. And then we could even, if we wanted to be able to use both of those inside a single function, we could define something called fold. You've probably seen it used around the place in different libraries. And we could actually handle both of those cases inside the one function. So great. We've managed to replace a nullable type with result type. And now suddenly our failing results tell us why it failed. And again, it's referentially transparent, so it should be easier to test. And now that we're encoding everything into the type and that we're kind of forced to handle it if it is a failure, we've kind of gained this type safety as well. Looks like we understand result type, right? There's more. So we got to go back to our description of this result repo that I showed at the beginning. There's something we haven't really covered here, which is this word monad that appears a few times. It seems it's mentioned twice. It seems like it's something we should get to the bottom of, right? So I don't want to try and go into the mathematics of monads here, or talking about its origins, or the specific rules that need to be applied for something to be a monad. I'm just going to strip that back and just try to define a monad for what you would need to understand from a coding perspective. We can kind of think of a monad as this abstract class that anything that is a monad needs to sort of implement. And there's kind of just three things that monad type would need to do. One is that you need to be able to construct an instance of it, right? So it's going to be some kind of value wrapped in whatever our monad type is. And then we're going to need it to have two functions, which are map and flat map. Now, this looks a little confusing, right? Like, what are these map and flat map functions? We're going to try and dive into what each of those are. And to do that, I'm going to use some pictures from this blog called that describes a monad, and it's the blog is called Monad in Pictures. I think it's a really good explanation for these things. So just going to grab some water. So map, what is it? Well, say we had a value 2, which is a concrete number, and we had our function that we saw at the beginning, add 3. Well, it's very easy to apply that number to the function, and we get back the output, right, which is a 5. But what happens though when our 2 is wrapped in some container, perhaps inside a monad? If we try to apply that to our add3 function, add3 doesn't know what to do with this new wrapper type. It only knows how to deal with integers, right? So we need a way to be able to sort of operate across these wrapped types. And that's where map comes in. So map lets us take our add3 function, apply this boxed type to it, and some magic happens, and hey, look, we get back that same box with our new value inside of it. What's really happening under the hood is that map is unboxing or unwrapping that value out of the box, applying our function to it, and then putting it back in the box and serving it back to us. So just to show you one kind of simple monad to think about this map type is the option monad. For those not familiar with it, it's very analogous to Kotlin's null safety type, or to Kotlin's null safety. I don't think can't call it a type, I suppose. But yes, same sort of idea. You have either you either have some object or you don't have an object, really. And here it's either some value or it's nothing. And what map looks like for this is that we're going to unwrap that value t and pass it into a lambda function. And then you can return any type u, and then that gets boxed back up into this option type. What that looks like then, so say we had a value x that we assigned to sum to, so it's an option of integer. When we try to add 3 to that, well, it expects an integer, so it's going to fail. Now, if we were to map over our x, let me see, do I have my little pointer here? Yeah, as you can see, when we call map, we're going to get access to the value inside. So we've unwrapped it, and then now we can call our add3. Add3 is going to return 5, and then what map is doing is basically rewrapping that that object that we had. So you could replace this whole call with just sum 5, and it shows it's it's referentially transparent. Let's go to the next slide. And yeah, and in the case of if we had none, so it was an option of integer that held nothing, when we call map, this whole thing just equates to still just be none. So what happens though if we had another function, say alphabet, that takes the index of a number to try to give you back that character in the alphabet? If we try to do the same operation here, when we map over it, we get a number. We unbox the 2. We pass it to alphabet, and alphabet should give us back the character C, right? So you would assume then that if we were to replace that whole function, we would get back some C, right? But that's not actually the case. If you recall, all that map does is unbox the number and then rebox whatever this returns, which, as we saw, alphabet actually returns back an option of character. So what this really is some C, which is a little nasty to look at. So is there a way we could flatten this? So that's where flat map comes in. So what flat map basically allows is that when we unwrap the value that we're applying to some function, in this case, the example gives that if it was not even, well, then either return the even number or return nothing. And what flat map is allowing is that you can pass in something that's wrapped and give back potentially a completely different wrapper with holding another value that isn't wrapped again by the initial box. Feel like I'm not explaining that too well, but hopefully it'll make more sense when we look at it in the context of this option monad again. So as you can see here, for flat map, then it takes the contained value t and should return back an option of u. And rather than getting back an option of option u, we just get simply back that option u. So in our example again with alphabet, we can simply make this flat map, and now we're getting back some C. So pretty cool. We started with a option of integer and we called flat map, and magically we got back a option of char out of the end of it. So starting to show like, okay, flat map seems to be able to do some cool stuff. And now let's kind of think about why that might be cool in the context of our original example of getting our new org info. So I showed that we had this fold function where in the failure case, we could present a toast message. Well, say we had an additional task we had to do now, which was to save that org info once we were able to extract it. If we were to do that in our current fold implementation, we'd now have to add that to the onSuccess path. And because save org info also returns back a result, we're going to need to fold on that now because, well, if the saving of the org fails, maybe we want to show that same toast error message. And suddenly we've got this sort of duplication of the failure paths, and it's going to get really nested and pretty ugly. And this is where we really start to see the power of the monad come into play. And with that, I did mention in the description of this talk that sometimes this type of coding is referred to as railway-oriented programming. Felt like I couldn't really not mention this in the talk. What is it? Well, Scott Flashing, I think, coined the phrase back in his talk in 2016. He's a F# developer, but he sort of proposed that we can think of returning types or these result types as this two-track system, where at any point we can switch rails from a happy path to this error path. And we have this ability to chain together functions that are result types together using flat map. So he gives this example of taking a list of strings to get to validate and send an email. And you can see that each of these functions is going to return a result of either the processed email or some kind of failure reason for failing at that part of the junction, I guess. So we have a parsing, a validating, and a sending. And at any point when he binds these tracks together or essentially flat maps them together, he can always reach the failure path. And what's also really powerful is that at any point, once you reach a failure track, you could always connect and recover to a brand new track that is a new success and failure track. So you can kind of picture that you can end up with this sort of infinite chain of train tracks. So Let's sort of put that into the context of our example and using flat map and sort of thinking about it in this railway orientated way. So we know that this fold is going to get kind of messy. So let's reduce this first down to a using flat map. Looks a lot cleaner already, right? We can now say that, okay, if we successfully are able to unbox this new org info, well, save the organization info. And if we were to picture that as a train track, well, now you can see that if at any point we failed, we're going to trail onto this failure path, but we're not handling that failure path yet. So, and we know that we want to show that toast error. So we could call that on failure here and present our error. So now we've flattened down those two calls to present the toast into a single one that's chained together. That might look something like this, especially if we allowed that our side effecting on failure could still return the original result type that it was accessed from. So we can kind of think of this as sort of this side effecting chain that just train track that ends there. And we could also have even more calls after that, right? So imagine we then wanted to switch tenant if this was the new org info was successfully extracted. So we could even flat map again, and the tracks just continue on. And we could even specify a recover after this to say, well, if any of those failed, I want you to switch to getting the actual known orgs. And now we have pretty much a brand new track, and we can continue on from there. So I think for some people, this really helps to think as sort of a framework for thinking about how you connect these different result types together. And with that said, I think we can kind of zoom back to the current, where we now, I think, understand everything there is to know about result types and what a monad is and how this relates to railway-oriented programming. And kind of get back to specifically talking about one implementation of result type, which is Kotlin result. Here is the actual implementation of result in the Kotlin result library that is authored by Mike Bull. The one thing, when I was looking around at different result implementations, the reason I really liked his version was that he didn't constrain the failure path to be of type exception. Someone once said, exceptions are for exceptional circumstances. And I think this really rings true, especially when you're already dealing with results. If you're using results in a code base, that probably entails that you expect that sometimes something might fail, right? So I don't think that's an exceptional circumstance. I think that's just like part of the normal execution of your system. And with that said, you probably don't want to be throwing exceptions when on the JVM they're already kind of slowed because they have to build up stack traces. And if you're already kind of encoding these failure paths, then you may as well use your own defined hierarchy of sort of specific errors that can happen, because at that point you don't even need stack traces, right? If you're if you know exactly why something fails, you can have very specific exceptions or errors that you've defined in like a data class, so that you know exactly why this result failed. And so that's why I really liked this implementation. Another thing just to note here about this specific implementation is that he used OK and error as the success and failure paths. So I think they're kind of shorter to write as well, which is nice. And now, what did I contribute to this, and why have I been contributing to it? Well, I guess one reason is what I just explained on the previous slide, but also I think the reason why I wanted to contribute was that I came from writing Scala before I'd switched over to writing Kotlin in the mobile space. And I was already kind of familiar with working with monadic types. So for me, I was already kind of invested in this type of programming. And then I was at KotlinConf last year, and I saw this great talk on exception handling in Kotlin, which I'll link to at the end. But I realized after watching that there were other people also interested in coding in this style and bringing it to the Kotlin ecosystem. So I went and looked at different result libraries that were around for Kotlin and saw that something was missing that is usually very prevalent in languages that have these monadic types. So what was missing? Well, going back to our kind of a reduced version of that example I showed before, where we're taking this info, saving it, and then switching tenant with that info. Well, here in every function is returning back this same org info, but that's probably not that realistic, right? Like the saving of the org info, maybe that returns a DB status. So in this case, really when you flat map, you're unboxing that DB status. And what if like switching tenant requires to know about both the org info and this DB status that you just got? Well, suddenly what can switch tenant actually fill in here? It only has the context of that. It doesn't know anything about the org info at this point. So the only way to really write this piece of code is with like nested flat maps. And I think this is something that a lot of people complain about with this style of programming where you're chaining things together, that it's very easy for things to end up getting quite nested. So the sort of solution to that in a lot of languages is something called the monad comprehension. There's some great explanations of what that is online, but Scala has an implementation along with many other languages, and it was something that I thought was missing from a lot of these result libraries. So that's what I went about trying to add to this Kotlin result library. And what we ended up settling on was something called binding, which is, I believe comes from the Haskell world. That's what they refer to this type of syntactic sugar as. But what it essentially is a way to make your flat maps neater or cleaner. So you define this, you call it binding, which expects this lambda. And inside of the lambda, you now have access to this new, I guess, receiver context where you can now call .bind on any one of your functions that returns a result type. And what this is going to do is it means that at any point where if one of these result calls were to fail, it's actually going to halt execution at that failure, and it's going to return the failing result from that call to our binding, and that's what we'll actually receive in our org info. So it allows you to basically in a more sort of step down style write your code, and without having to get into this sort of nested looking spaghetti stuff. So I think it was really useful to add. We even got it working for coroutines, so you can have this code working with async calls, and it will, we have a pull request open at the moment, so that if, say, you were to use async and one of them was to finish before another one in a significant amount of time, it should eagerly cancel all other calls, which I thought was pretty nice. If you want to look into this more, talk about it, feel free to ping me afterwards. But yeah, overall result, what do I gain? Well, as we've seen, you get the modeling of success and failure. Along with that comes referential transparency, type safety, simpler tests. And if the result type that you use is of type monad, or is a monadic type, because there are some result implementations, such as the internal Kotlin results type, which is not a monad. Yeah, you're not all of them will be, but if it is a monadic result type, you're going to kind of get this composability as we saw from railway oriented style. You're going to, I believe, you get readability once you start to write it in this way. And I think reasoning speed, because I think once you kind of start to think about all of your functions as things that can return results, it becomes quite easy to be able to like chain them together and not have to focus on what's happening inside them, especially if they're referentially transparent. You don't need to worry about these side effects happening. Of course, a lot of what I just mentioned as like pros could also be seen as downsides. I think there's obviously kind of a learning curve to thinking about this. Well, not only the sort of different jargon that floats around, but also a lot of these libraries have sort of assume a pre-existing knowledge of the meta language associated with container types, monads, streams, so flat map, flat map, fold. There's a lot of things that, you know, they already kind of assume you might know them. If you were to pull it in as another library, it's going to be another dependency in your code base. If you're already dependent on Rx, you can kind of achieve similar results if you like using singles. But again, this could be seen as a pro that if you already know Rx, switching to using like result types isn't going to be that unfamiliar, I think, with that style of programming. It does kind of impose a coding style, I think, if you're going to use results, which could be seen as a downside. I added exceptions for flow control anti-pattern. I have seen some people got, when I was trying to do something similar with Rx, I have seen people say, oh, well, are you not kind of encoding a path that you expect into the sort of the catching case, right? And I would argue, and I've seen it argued online, that that's not the case, due to the fact that with result, you have to handle either the happy or the failure path, unlike with if you were just throwing an exception and using that as part of your flow control. That's on you, whether you're going to try and catch that or not. Finally, maintenance. You know, unlike if I think this kind of comes back to this idea of if we had union types in Kotlin, how good it would be. You know, if we swapped a type from nullable back to non-nullable in so using Kotlin's null safety, you know, we wouldn't have to go and update all of the call sites in our code base. But if suddenly we knew that one of our functions always returned the same thing, and it used to be a result type, well, now you're gonna have to go and change all of your call sites that expected that function used to return a result. So that could be seen as a downside to using result type as well. Probably big elephant in the room. People are wondering, well, what about arrow? Why haven't I mentioned that? Why aren't I using the either type that arrow provides? Well, first off, if you've been kind of following arrow, you'd know that there used to be a try type, which was essentially what we kind of talked about with result. That was deprecated, so that's gone. I think probably just something to mention about, like, don't get me wrong, I think it's an amazing effort. I think it's a really cool project, and I love that to see that it's like growing and there's a lot of popularity around it. But yeah, it's still like not at a 1.0 release, so it's kind of unstable if you want to try and like use it right now. The other thing to say is that the last time I tested out the monad comprehension feature that the either type provided, this was in the 0.10x release. I did some benchmarking against it with the binding function that we use in Kotlin result, and it came out really, really badly. I will just show, and I think a lot of that is due to how they were doing it under the hood. So there was, I believe they used like reflection, and because everything's like using these type classes, there's a lot of overhead for it to work. That said, talking about performance, we do actually have JMH, which is Java Micro Benchmark Harnessing, in Kotlin result library, so you can check that out afterwards. But we were able to benchmark the flat map, which is, and then is kind of like an alias for it in Kotlin result. We were able to compare that against the performance of binding. The test that I actually wrote to do this might be a little contrived. I'm in no way an expert on JMH, so if anyone wants to go check that out and see if there's ways to improve that, please go ahead. But yeah, as you can see here, this is just using the default throughput of operations per millisecond from JMH, and you can see that when you have a binding call where everything successfully binds and, you know, everything unwraps correctly, it is a slight bit slower than the other three. Kind of interesting to see though, if you had a failing bind in the similar case, it's actually going to be probably the fastest. At least this was the case on my machine. But yeah, it would be cool if anyone's interested to actually update our benchmarking in the repo to maybe even compare it now against the 0.11 release of Arrow, and perhaps other Kotlin or other result libraries, even the internal result type. But with that, yeah, what did we learn? today. Well, I hope you learned about referential transparency and have some kind of idea of what that concept is now. We learned that you can encode exceptional behavior into a type signature with a result rather than just throwing. You kind of got a brief overview of monads and the power of flat map. And we also learned about result and railway-oriented programming. You learned that the Kotlin result library implementation is the best one around and monad comprehensions are the best. And we also kind of looked briefly at some of the downsides to this approach. What did we not learn though? There's probably, too much to cover. One thing I didn't really go into was how categorizing and organizing errors if you're going to use a result type. So rather than me try and give a poor description of that, the talk that I'll link, the error handling strategies Kotlin talk at Kotlin Conf 19, has a really good, he discusses lots of approaches to avoiding stack trace exceptions and like what happens when we try to switch to a result type, and the fact that you're going to start having these like large lists of custom exceptions and you need to decide how you're going to manage them. And I think he does a very good example of, or the two guys who give that talk give some good examples of what you could do. Did we kind of talk about alternatives to using results that are still in this sort of functional vein? Not really. I did kind of briefly mention that union types would be great, but Kotlin doesn't really have a way to support that right now. So something you might be interested to look into more after. In terms of functional programming in general, there's a lot to cover, that we didn't talk about. So, collections are usually implemented in like a recursive way when in a pure functional programming setting. We didn't talk about higher kind of types or how you actually encode side effect encode into a type, which is a whole topic called effects. But yeah, just sort of things that you might want to go look up afterwards. Where to from here? Well, I think the stars of this repo has actually climbed now up into the 300s. Please go and star it and maybe use it in your enterprise code project would be cool. And there's a couple open issues, some pull requests. We're currently in the process of adding both an iOS and a JS target for the Kotlin multi-platform build. It supports multi-platform. So yeah, please go check it out. I'm going to dump in a message to the Kotlin Lang Slack Dublin channel, a huge bunch of links that you might want to go follow up afterwards, and feel free to discuss it there or ping me directly on that, anything you want to learn more about. With that, I'll open the floor to Q&A, and just left a little link to this. Please, I would highly recommend joining the Kotlin Lang Slack. It's open to all to join. But that's everything. Thank you.
Awesome. Thanks very much, Tristan. That was really, really good. Excellent talk. Really well explained, really good story, really thorough. I think covered an awful lot.
That's my one fear. Maybe it's a little too much for one talk.
I think it's good to mention the things you didn't cover as well as the things you did. We're really fantastic. So well done and thank you. Particularly enjoyed the pictures storytelling. My favorite was the golem with the programming ring to rule them all. If people have any questions, feel free to unmute yourself and ask or post in the chat. So we've one from John O'Reilly that I think you might have just answered at the end. So have you seen use of Kotlin result in a Kotlin multi-platform project and in particular Kotlin native?
Yeah, I can't say that I've actually seen it in use yet in a project. As far as I understand, because it's there is just the JVM target right now, that it should work in a Android and KMM project. As far as I know, I haven't actually tried that out yet, but I assume that works. And as I said, we're in the process of trying to add the iOS and JS targets, so should be possible soon.
Great. I thought. So we kind of I guess evaluated a good few of these options in the last year. and moving away from exception or trying to move away from exceptions entirely, other than for obvious programmer errors. But yeah, I guess we were previously on the creating our own domain specific result types until you shared this library, and we started looking into it a bit more, and yeah, just found it solved a lot of the issues with the other solutions really well. Like I think with the the either option from Arrow, I think it's really good, but the thing that it just can't get past is the left and right naming, that you have to know that left is there, and yeah, it's just a little bit of readability. And also the testing I found has been a big factor. Like if you're trying to test with exception types, and even like using exceptions in your result types, that you just like can't really assert against them properly. If there's stack traces in them, they're like serializing them and asserting against that is a no-go really. Just a question on the performance. So the benchmarks you show, so it's really good to see the benchmarks, because yeah, it was something I've been meaning to look in a bit, like how bad is the exception throwing performance. So were the benchmarks you showed, you were comparing the results object to was it Arrow?
So that one I showed was actually just I can actually jump back to that slide. Let me go back to it. So this is actually only comparing. So Kotlin result library obviously had a flat map implementation for it to be a monad, and then it has this. I guess it's like kind of like an alias called and then. So you can think of that as that's basically just flat mapping. Comparing that, all I added was, because I knew I was adding this binding keyword, I just wanted to see how much slower is it to write your flat maps inside this binding block. And so that was the only thing I benchmarked, was sort of against the only gold standard I had to go against was what was already in the repository. Okay. So this is really just comparing, like, here's the new thing I added that you can use against the already standard way of chaining results inside of that library. I did, however, in my very initial explorations, I had written a benchmark also against using either from Arrow from this 0.10, and just to put that in perspective, this is in the hundreds of thousands of operations per millisecond. To do the exact same call with Arrow effects binding, it was getting under 1,000 operations per millisecond. So that it really puts it in perspective of how slow it actually was. But of course, I'm not an expert at this, so I don't really have context of like what it means to be at the hundreds of thousands of operations per millisecond versus under 1,000. But it was the only sort of I needed some kind of marker to go against, right? So that was it, really. It was interesting though, you mentioned about that the either being left or right encoded and having to know that. I think that's kind of why I like result type that little bit more, that it is specifically saying, well, it's either a success or a failure, rather than either just being this sort of general left or right, and kind of just having to know about that sort of is this something you just got to know?
Awesome. That's really interesting. Yeah, good to know. Do you have any idea off the top of your head, like how bad like throwing an exception is for performance?
Oh, no, I don't. That talk did mention that it's that it is slow having to build up the stack trace, but yeah, no, I don't have that info. But it would be cool as well to have some kind of benchmark added to show maybe the difference in having to throw the exceptions.
Yeah, definitely.
I see there's one more question there around do you think referential transparency is important for declarative UIs? So yeah, of the little I've looked at Compose so far, I know that I guess each of these composable functions, right, is like something that's the idea is that it is sort of pure. If maybe I'm getting that wrong, but as I understand, inside a composable function, you can have a side effecting action, right? Like some kind of you can have handlers of some kind that will operate when something is clicked or whatever. I guess that means that the function itself it would be referentially transparent, that you could replace what it does with a call, but or with the outputted UI. But I think, yeah, I don't know how you get around the fact that well, no, yeah, it probably is fine, right? That all you're saying is that you can replace the composable function with its returned output. If it happens that that returned output has a handler to be able to invoke something, that's fine. But whether it's actually important to be thinking about when building them, I'm not sure. Yeah, maybe in sort of principle, it's kind of cool to think that they've been designed in a way that is very functional. But yeah, I don't know if you need to keep it on top of your mind while you're building these things.
Sorry. Cool, thank you. And thanks Ian for the question. Any more last second questions before we jump on to Cesar? Okay, brilliant. Thanks again, Tristan. Really fantastic talk. Really enjoyed it.
Thank you.
Sure. So we'll hand over to Cesar.
Sure. Let me share my screen. Okay. Can you guys see it?
Yep.
Cool. Okay. So, hello everyone. I'm Cesar Munoz. I'm a software engineer at Toast. I'm most of my work it's in Android development, and I wanted to talk to you about how to write a Kotlin compiler plugin, but a practical approach. And I'm going to explain it a bit further in the next couple of slides. So let's start with, what is a Kotlin compiler plugin? In a very try to simplify way of maybe showing it is that so far we have these kind of stages when we are writing code. In Kotlin, we have we write our code first, and then it goes through the Kotlin compiler, and then depending on the platform you're targeting to, it's gonna create the code that is needed for each platform. So it could be Java, JavaScript, or native. By the way, now that I'm talking about these platforms, just please bear in mind that mostly my background is in Java. So most of the things that I'm going to be talking about here are going to be kind of some sort of comparison with the Java environment itself. Although don't worry, if you're not targeting Java, the idea is that the Kotlin compiler plugin can also work for the rest of the platforms. So a Kotlin compiler plugin could be something here, right in between the compilation and the platform compile code, and we can see it as just something, an extra layer that intercepts the code that is being compiled. And in this layer, you can add your own what they call extensions that allow you to modify the code as much as you like to. I think a good way of kind of understanding how this is useful is with an example. So let's say that we have this function here. It's a simple function, takes 2 arguments, returns one string, it takes 2 string, and then it just concatenates them, and it returns that concatenation. It's pretty simple. Let's say that we want to add this sort of log that shows that this function is being called, and it shows the values that are passed to it. So we can add that with a Kotlin compiler plugin. And the reason why it's useful, well, even though this is a very simple case, the reason why this is useful is that I've seen this kind of logs in some projects, and it tends to be something that gets overlooked in time. So if the function name, for example, changes, then you will have to, make sure that the strings are also updated. Or if you add or remove arguments, the same happens. So this is why it's kind of some cool thing to have it automatically generated for you. So usually in the Kotlin compiler plugin, you have to somehow let your tool know which is the function that is going to be modifying. So you can do so by maybe the name of the function itself, or also the amount of arguments, or also the class that the function is in. But usually when it comes to generate some code or modify some code, it is very handy to use annotations in order to identify which is the functions that you want your plugin to modify. So this is pretty much it. This is a very simple example. I'm gonna go through a couple of very common use cases of what people tend to do when it comes to modifying existing code. So the first is what we just saw, which could be logging. Some people use it for exception handling. Yeah, some people just don't like having to wrap everything in some try-catch blocks. So this is something that could be auto-generated for you. This is a classic one. This is for performance. People tend to add this to kind of grab their code in, so that they can get the execution time, or how long it took for it to run, so that they know if that maybe there are some methods in their code that are taking too long. It's something that is very useful as well, when you can modify the code. And then also, when you need to validate something before the body of the function gets executed. For example, there are a couple of backend framework. I'm not a backend developer, but I've seen, for example, in Spring, that they have these annotations where you have an endpoint and you don't want any user to hit that endpoint. So you want only authorized, authenticated users to be able to access that code. So you can have annotate that function so that it can verify that the user is authenticated before it proceeds. Otherwise, it returns some sort of error. So this is also a pretty common use case. And lastly, for me as an Android developer, this is a very this is a case that is very useful for me. So, for example, in Android, there's a couple of things that before you can execute them, you need to make sure that the user has granted the right permissions to your app. So let's say, for example, that you want to take a picture. You need to open up the camera app in order to do so. But the thing is that you need the camera permission. So you have to make sure that the user has granted it before. You can do so by writing something like this. And then after you have confirmed that your app has the camera permission, you can proceed to open up the camera. But if you don't have the permission, then you have to write something like this, which, by the way, has changed recently. Google this year has released a much cleaner way, let's say, to to request for permissions, but for a long time, this was what you had to do. And I think it's just a good example. So you had to run this code made from an activity in order to request for a permission. But the thing with this code is that you cannot get the result from what the user ended up doing right here, but you had to override a method from the activity, or so that you can get this kind of feedback later on, and then you can then check if the user has granted the permission you need, and then you can proceed to take your picture. So with a Kotlin compiler plugin, which allows you to modify code, not only modify code, but add new code, you could take all of these and then just have it like a annotation where you can specify what kind of permissions do you need, and everything else is auto-generated for you. So I think for these kind of cases, I really like when we can generate some code, modify the code, which is something that the Kotlin compiler plugins allows you to do. So a couple of key functionalities, and some sort of, just to give an idea of why this tool is it's really cool, at least compared to what Java offers as a built-in tool. So you can create new code with the Kotlin compiler plugin. It's something you can do with Java as well, with the Java annotation processing API. It's not exactly the same, but at least you can create code using this API, which is built in Java's tools. But the thing is that with the second thing is that you can modify existing code. But with Java, there's no way to do that, at least no using the original built-in Java's APIs. So it's actually, for me, it's very important that the Kotlin compiler itself adds this kind of functionalities in the official core of its own platform. So I think that's really cool. So how to write a Kotlin compiler plugin. There's a video in YouTube of a Kotlin Conf back in 2018, where Kevin Most, he explained how to write a Kotlin compiler plugin. I think this video is very important for someone who's looking into create a Kotlin compiler plugin, because it's kind of like the only thing that you can find out there right now that actually explains to you how to do so, because there's not much, I think there's no documentation at all for anyone where you can actually find some sort of guide, some sort of tutorial on how to write a Kotlin compiler plugin. So I think that's why this video is very important, because it actually takes you through all of the steps that you need to make in order to write your first Kotlin compiler plugin. It's a very nice video. If you haven't seen it, I highly recommend it. The reason why I bring this up here is because there's a couple of things that happen in this video that I'm gonna talk about a bit later that kind of made me wonder if there was an alternative way of doing the same that Kevin was trying to do, or what Kevin did in his video. So I'm going to use this video as a reference in order to explain why we're going to talk about a different way of essentially doing the same. But to me, at least, it's a bit more friendlier way. So let's see. For a Kotlin compiler plugin, we first need to So we're going to write a Kotlin compiler plugin. We need to know what we want our compiler plugin to do. So in our case, let's say that, again, we have this function here. So what we're going to do, or what we're going to make our compiler plugin do, is that when the consumer adds this annotation to one of its methods, wherever it is, our compiler plugin is going to add first this sort of log that shows that this method is being called and what are the parameters, or what are the values actually that are passed to it. And then we're going to do the classic tracking of the execution time of our. I think it's important to mention here that this exact same use case is what Kevin was talking about in his presentation. And I think it's good that we try to do the same as well here, so that we can kind of compare a bit better these two approaches, the one that Kevin was talking about, which is actually the official one, and the one that we're going to see in this presentation. So this is what we want to do with our Kotlin compiler plugin. So let's see how to do that. I'm going to talk very briefly about usually what it looks like, or what are the stages that you have to do in order to write a Kotlin compiler plugin. Please notice that this is something that is very, very, very well explained in Kevin's video. So I'm just going to talk very briefly about it. But if you really want to know exactly what is done specifically in each of these stages, please have a look at Kevin's video. But in essence, you basically have to start off with a Gradle plugin. Then the Gradle plugin, you can add some Kotlin dependency to it, so that you can create what they call a Kotlin subplugin. So this Kotlin subplugin is then later going to connect, or it's going to fetch the actual Kotlin compiler plugin, which should be in a separate module. And then finally, the Kotlin compiler plugin is the place where you are going to kind of register your Kotlin compiler extension. And this part here, the last part of all of the process that you need to make, is actually where you have to write the code that you need for your compiler plugin. So this is the, I mean, all of the parts are important, but this is the one where you are actually going to write your code for your compiler plugin. So in essence, this is the part where we will need to do what is highlighted here on screen. So now the reason why I would like to show you an alternative on how to do this compared to what Kevin did in his video is because when he reached to this part, he shows that the way that he had to write this code that modifies the consumer's code is that he doesn't do that in Kotlin or in Java code, but he uses ASM instructions. So ASM is a tool that allows you to modify Java's compile code. Basically, ASM by itself it isn't an acronym. It doesn't mean anything. But the creators say that it's just a reference to some functionality that you can get in the C language that allows you to write some assembly code. So just to show you how ASM looks like. So here we have this function in Java. This, yes, pretty simple function, just hello world. And then if you want to achieve sort of like the same as this function in Java, but with ASM instructions, you will have to do something like this. So it's kind of like you will have to have, let's say, kind of like a low level knowledge of how Java works itself. And I'm pretty sure that most of people don't know that because they don't need to. And it can be perceived as something that might be maybe not worth trying to learn based on the benefits that you are trying to get from it. But in any case, Kevin, he explains this a bit better in his presentation. If you want to know exactly what he was trying to do in order to accomplish the same results, please go to see his video. He has really cool animations explaining how all of the instructions work, and it's very informative. But the thing is, this is the reason why I was trying to find an alternative, because when you look at this code, to be honest, I'm not even sure if it can be considered as a programming language. It kind of seems more like a set of instructions. But the thing is that, let's say that you want to learn it, and you kind of see that there are a lot of strings. You're gonna see that there are a lot of kind of like classes, full names, but that you have to know them. So maybe see, if we consider this as a language, then you have to learn all of the things that you need to do with every new language. If there are good practices, if there are ways that you can avoid maybe making mistakes in order to avoid writing some string that might not be the one that actually the Java platform is willing to accept. But in the end, when you are actually, if you decide that you want to learn this, and you do that, and you take the time, and you succeed, then in the end, your Kotlin compiler plugin will only work for Java, because you essentially have written some Java compile code. So let's try to see if there's an alternative that saves us this part of ASM instructions. So there is, and it's actually quite funny, because anyway, let me show you. The alternative way is using a third-party library that kind of serves as intermediate in between your code and the Kotlin compiler plugin API. So this tool is called Arometa, and I'm conscious that this is the second presentation that we see in this meeting that mentions something about Arrow. I really wasn't expecting that, but yeah, I guess it's a nice tool, and so we saw that it in the two presentations of today. So Arrow, they have this tool called Arometa. They say that it is used for meta programming, and it kind of connects your Kotlin code to the Kotlin compiler plugin and API, and it does so in a kind of a very friendly way. So I'm going to show you just quickly. They have this really cool animation in their website, which I'm going to send the links to at the end of the presentation, where they kind of show you how it works. You basically write the code, and it looks like it's actually Kotlin code, the one that you have to write. It doesn't have to be ASM or any other platform. And then they replace the original code with that code that you wrote. So for our example, by the way, don't worry if you didn't see all of the details of the animation. It's in their website, and I'm going to share the links at the end. So for our example, what we want to do in the end, it will kind of look like what you see on screen right now. Don't worry if there's a couple of things that don't seem quite intuitive right now, because later I'm going to be showing you the code. But just to have a very quick reference of what we want to do, instead of writing the ASM instructions, is something like this. And it actually looks, I mean, in the end, we have to return a string, a very big string that contains just Kotlin code. So in the first line is actually this function. Well, what we're going to be doing is that we essentially are going to be replacing the original function. But we're not going to replace the body of the function itself. We're going to replace the whole function. So that's why we have to define the definition of the function, and this method here, get function definition, it basically just gives the whole definition of the original function. So in the end, from this method, we will get something like font space, the name of the function, some arguments, the return type, etc. And that will be it. And then we have here, well, we add our code, we add the log that we want to show. We get the start time, and then here we actually can call the original function body, and we can store it in a variable there, which is named result. Then we do everything else we need to do, and in the end, we make that this modify function returns actually what the original function was meant to be returning. So this is, to me, it looks way nicer than having to write the ASM instructions. And the good thing about this as well is that the guys from Arrow Meta, they say that the same kind of code, the same plugin that you write with them is going to work for all of the platforms that Kotlin supports. So I think it's really cool. This is an alternative right now. Now, even though it looks cool in comparison to what we had officially for writing a Kotlin compiler plugin, it's not all rose-colored. There's a couple of things that are quite not intuitive, and especially the setting up of Arrow Meta. It kind of requires you to take a look at some things in Gradle, in the build.gradle files that you might not be familiar with. So I'm going to be explaining those things right now. So essentially, for our example, we need two modules. One is going to be the producer one, which will contain our Kotlin compiler plugin code itself, and then the consumer is just going to use that compiler plugin. So we start off with the producer build.gradle file. This is how it looks like in the producer project. We say here that we have to add this dependency. This is the compiler plugin from Arrow Meta. We add it here. This is so that we can use their code. For writing unit tests, we need to add the meta test module, and in the bottom is the same compiler plugin that we added before. It's just that I added also for it to be available in tests. Now, you might have noticed this, which is kind of different from what you might be used to in order to define a dependency in Gradle. This is just a new custom name for defining dependencies that it works because we have defined it here. And the reason why I defined this custom configuration is because it will come in handy later on in this part where, yeah, we're going to collect here all of the dependencies that were defined using in this case fat dependency configuration. The reason why it's called fat dependency is because what we're doing here, okay, the reason why we need to modify this Gradle task jar is because as part of our producer code, you know, when we compile this code, this is a Java project, it's going to generate this jar file, and we need it to be what they call a fat jar file, which is a jar that contains also dependencies in the same jar file. So for our case, we need to embed in the same jar file all of the code from the arrow meta compiler plugin, and this is how we do it. We basically collect all of the dependencies added with this, which the only one we have is the compiler plugin. Oh, sorry. We collect them all, and then we basically what we're saying here is that we are going to be moving all of its contents into our jar for our producer project. Then lastly, we see here that we are telling this instruction here to Gradle that it should exclude this kind of file. So it should exclude the file that is named component registrar. And the reason why it has to do so is because our producer project is essentially for the Kotlin compiler plugin API is also a component registrar. It contains its own, and that's the one we need the consumer to use. So we need to exclude that file, which is the exact same file, the exact same name, from the Arometa compiler, so that it kind of doesn't have any kind of conflict, because we already have for our producer our own component registrar, and that's the one we need the consumer to see. So this is it for the producer project. Now let's see the consumer one, the build upgrade. In here, both modules are in the same project, but you will see later. We add here our producer. We also have defined a custom configuration for it up here. And the reason why this is useful is because later on, we're going to be using it here when we need to modify the compiler Kotlin Gradle task in order to use our plugin. So basically, this task is available in any Kotlin project. And what we're doing here is that we are modifying it. We need to modify it because we need to add an extra command for when it is executed. The command that we want to add, the command option that we want to add for it is this one. This option allows you to pass a plugin for the Kotlin compiler. Essentially, these functions, this option, sorry, receives a jar file. So what we're saying here is that we collect all of the jars that are defined with Kotlin C plugin, we only have one, which is our producer. And then in turn, this is going to be a jar in the end. And then that jar is going to be added here. So here is where we are actually, this is the most important part, which is where we're actually telling the consumer that it needs to use our plugin in the Kotlin compilation process. So that's it for the setup. Now let's see it in action. Here. So we have here, this is a project, the sample project. I don't know if there's a way to share it with you in the end. Maybe I'll check with Tom later. So in this project, we have both the consumer and the producer modules. So if we take a look at the producer, well, here's the Great Valley's got comments in the case that you want to know exactly what everything is doing there. So this is the producer. The way that we define a plugin in the, that works with arrow meta is by creating this class that implements this meta interface. In order to register as a plugin for the Kotlin compiler, we need to annotate it. This is a Google tool. It's called Auto Service. It basically sets this the path of our plugin into as a component registrar in the generated jar file. So this is basically the part where we say that this class is actually our plugin. So when we implement this interface, we need to override this method. And then this method, we need to return all of our actual plugins, or maybe in the official way of doing, of writing a Kotlin compiler plugin, they will be called extensions, which is where actually all of the code modifying happens. So we added, at least with the only one that we created for this example with our plugin, and we see it here. So this is actually where the magic happens. We see here, we define the plugin, state extends CLI plugin. We need to set a name for it. And then we, inside this meta function, we have to first figure out a way of kind of filtering or kind of identifying what are the functions from the original code that we want to change. So for that, I created this method where I just check that is if the function has my annotation, that's what I call it, then it's a function that we should modify. Then once it gets here, because it found a function that is annotated with that annotation, we call this transform replace method. It receives the function that's been replaced, and then it also receives this parameter where we have to pass the replacement of that function. So the replacement of that function is what I was showing you earlier, where we finally define what's going to be, or what's going to look like the new function, the new modify function. So here it is. Essentially, we get, well, this is the function that gets kind of like the definition of the original one. We're just basically getting from the original function its name, its arguments, and then its return type, and then we kind of shape it in a way of defining just a regular Kotlin function. That's pretty much it. And then we have this other method where it goes through all of the parameters that it could find in the original function. It gets their name, it gets their type, and then it joins them in a single string that kind of represents the same way as we define the parameters of a function normally. And the other functions are specific for this example. I'm not gonna go through them, but if you can take a look at the code, please do. It's just helper functions for the specific functionality that we want our plugin to achieve. So this is pretty much it. It looks, as I say, it's just Kotlin code. We get the start time, we get the result from the original function, we get the delta, and then we print how long it took, and then we return the original function result. That's pretty much it. Now, let's take a look at the consumer. In the consumer, we have, this is the only class we have. We have these two methods annotated with my annotation. So we have this public one. It's a simple one. It just adds two numbers. It sleeps for half a second, just so that we can see that in the logs. And then I created this second one. It's just to show that it doesn't matter if the function is either public or private. It really doesn't matter, as long as if it's annotated, it's going to be modified by our Kotlin compile plugin. So I have a couple of tests here, where in this first test we call the first function, and then we pass 5 and 7, and then we see here our log that was added by the plugin, calling this method, and this is what it received, and it took this time to finish. The same happened with the private one. And as I was saying at the beginning, you see here the name, some private function. We can rename it, and it will work. Now we see the new name of the function there in our logs. Something else, and yeah, that's pretty much it. But this isn't the only way that you have to verify if everything is working, because as I was mentioning before, in the build.gradle for the producer, we have this meta test module where that allows you to write unit tests also for your producer. So essentially here we have two tests. In the first one, we have an input method that is annotated. This is what we expect it to be after it's processed by our but after it's processed by our Kotlin compile plugin. And that's pretty much it. We can double check that here. This is all part of the arrow meta testing module. We pass our plugin, we pass the input, pass the expected output, and that's pretty much it. Then we have this other test where we verify that a function that is not annotated with my annotation doesn't change. So we pass it as both input and output. Remember, I was saying that there's a couple of things with this tool that are not we see here this sort of comment meta debug, and you must add it to your function in the tests, otherwise it won't work. I'm really not sure why. I'm sorry, but the point is that you just have to add it. And I don't think it's intuitive, but it's just how it is. And a couple of things more, but anyway, just to let you know that if you happen to use this tool and then you see that your tests aren't working, most likely it's because you haven't added this comment here. Okay, so back to the slides. The final thoughts. And in these final thoughts, I'm gonna be just mentioning some thoughts that I had after what I've seen in Kevin's video and with Arrow Meta. These thoughts are both maybe good and bad at the same time. Everything's mixed up here. So let's see. The Kotlin compiler plugins is a promising new tool. And when I say new, it isn't new. Actually, we have been using a couple of Kotlin compiler plugins. I don't know if you have, if for example, you have used Parcelize, that's a compiler plugin. If you have used Android, Kotlin Android extensions, that's another one. But the thing is that what I try to say with new is that maybe it's just that new when it comes to develops one, and you don't work at IntelliJ. So it's something that it's kind of difficult to find some documentation right now. Is actually the second point that I added here. It lacks documentation. The third point here with Kotlin compiler plugins is that you need different extensions to different code for each platform. Although this is something that is changing. I've seen some recent news on the release notes for Kotlin 1.4 that they are working on some sort of single sort of code that you need to write just once, and it will work for all of the Kotlin platforms. They call it IR, intermediate representation. It's in alpha. I haven't been using it. And it's actually very difficult to try to find how to use it. There's lack of documentation. So it's still in alpha. They say that they're working together with Google in order to develop it. Apparently, rumor has it that this is what Google is using for their composable library. For Arrow Meta, we have that it's, I cannot minimize this. Okay. It is in essence, it is a Kotlin compiler plugin. It's just that you don't have to deal with all of the APIs. It works as an intermediate between you and the Kotlin compiler plugin API. It's got a friendly function replacing API, as you saw in our example. They say that it's multi-platform. I didn't try it in other platforms, sorry, but well, they say so, and it must be true. But it's quite complicated to get it set up, as you saw. There's not too many examples. They have, and I added a link at the end of the slides. All of these resources are at the end of the slides, but there's a project of Arrow Meta examples that don't have too many of them actually, and it only has 2 examples, and those 2, they don't show how to write unit tests. That's something that I found elsewhere, and they have quite short documentation, and they require you to have some knowledge on IntelliJ PSI Elements API. Just to go quickly through why this is important, here in the producer, the PSI element is basically these original functions that we get, and the reason why we need to have some knowledge on them is because it's some sort of tree architecture of elements where you navigate through the code using this API, and then that's how you can get things like such as the function name, the return type. But the thing is that it's not very I guess, intuitive. When you get the function, maybe you expect to just call return type, but to get the what it's returning, but no, you have to call all of these things so that in the end you can get the actual return type. Not only with that, but also with annotations. I must admit there's something here that was quite complicated for me to achieve by using these PSI elements, is that I wanted to get the full name of my annotation with the package name and everything, and I couldn't. There must be a way, but I couldn't. In the end, all I can get is just the simple name of it, which essentially any annotation that's called the same will work. So maybe that's something you don't want to for your brand. I'm pretty sure that there must be a way to achieve it, but I couldn't find it, and that's why I added here PSI element knowledge. And lastly, for some reason, and maybe this is a mistake I made, I could only find snapshots of their artifacts. For some reason, I couldn't find release versions. I did. You can find them in Maven repo website, but when you try to download them, they're just not there. I don't know if it's maybe I didn't add the proper repo or something, but I could only find snapshots versions. So in general, I just want to finish this with, I think compiler plugins are a really, really cool tool. They could be really, really useful. In general, you know, they're working on this alpha version of what they are, what we will be needed to just write our Kotlin compiler plugin once, and that's really cool. But so far, it seems like it's kind of too new. So if you are kind of really want to create your own compiler plugin, and you don't want to deal with at least for Java, and you don't want to deal with ASM, maybe you should try Arometa. As you saw, it's quite straightforward, but it's got also its couple of downsides. So I guess Arometa will be a nice way of creating your compiler plugin that works right away for all of the platforms. But personally, I just want to end up with a recommendation here. If you want to kind of do the same that these Kotlin compiler plugins do, which is to modify the code, and you are only targeting Java, I recommend you to use a couple of tools in the meantime while the Kotlin compiler plugin API is still in alpha, but maybe when it's ready to use, then definitely that's the best choice. But in the meantime, if you're only targeting Java, I recommend you to use Java's tools that have been there for quite long and have the same capabilities of modifying the Java compile code. So I'm just gonna, there's a lot of them, but I'm just gonna talk about the two that I consider are the most important ones. The first one will be Aspect-J. It allows you to do what it's called aspect-oriented programming, AOP. It works right away in any Java project, regular Java project, but in Android, you need to do a couple of Gradle magic in order to make it work. Although don't worry, there's an Android adapter plugin, Gradle plugin, that allows you to use it in Android projects. This is roughly a very, very simplified example of how an aspect could look like. You kind of define a class, you say it's an aspect, and then you kind of define some what they call point cuts, which is the way that you can identify where the aspect is going to do its magic. and then you say, well, before that method, I need you to run this code, and then you also have an after annotation, an around annotation. So it's pretty cool. I'm not gonna go into the details here, but just gonna show it. And there's a couple of, this is a couple of tools that use Aspect-J. If you're an Android developer, you might know Hugo or Hugo, I don't know how it's pronounced, but it does essentially the same as we did in our example. And Firebase Performance Monitoring also uses Aspect-J. So it's a mature tool, and it's the first alternative. And the second one is ByteBuddy. For me, this is my favorite. Again, it doesn't work in Android in Android right away. You need some sort of adapter as well. I couldn't find an adapter as the one that I show for Aspect-J. So this link here, it goes to my repo where you can find this adapter I call Android Buddy that allows you to just basically use ByteBuddy in Android. Please go take a look if you're interested. It does nothing fancy at all. It's just an adapter. It just kind of connects the Kotlin, the Android compilation with ByteBuddy. This is kind of like what ByteBuddy API looks like. You subclass a class of the project, then you find the method. In this case, we're going to override the toString method, then you intercept it, and we are here saying that the method is going to return hello world, and that's pretty much it. And then when we create an instance of that class, we receive what we just changed there. A couple of tools that are using ByteBuddy are Mockito and Hibernate for the server guys, and well, a lot of other tools, actually modern ones. It's a very, very powerful tool. Lastly, just to finish up with this note, if you're an Android developer and you kind of liked what you saw earlier, where we turn everything, all of that boilerplate, to request for a permission for your app, and you kind of liked that you could do so with an annotation, well, please go take a look at this library. This is an existing library that I made. It's called Upper. You can find it in this link. It uses ByteBuddy, and it essentially does exactly what you saw, which for me, it's really cool way of avoiding writing boilerplate. These are the resources, all of the links that I was promising in the previous slides. And I think that's pretty much it. If you guys have any questions.
Great. Thanks very much, Cesar. That was really good. Really interesting tools. Very, very powerful tools, and some cool use cases that you showed there. So some questions from Tristan. So what's the main difference between this and Square's Kotlin Poet and Google's KSP libraries? Is there advantages between each, or just a different offering?
Kotlin compiler and Google's, sorry?
So Square's Kotlin Poet, which I think is for generating Kotlin code. I haven't used it. And Google's KSP libraries, which I'm not sure what the KSP libraries are.
Yeah, sorry, I don't know those libraries either.
I think one of the things we were talking about before is like the advantages of the Kotlin compiler plugin over kind of code generation tools and AOP is that you can modify code with the Kotlin compiler plugin, whereas you can just like add new code with the AOP.
With the Java's built-in tools.
Yeah.
Yeah, no, sorry, I don't know about those libraries. If they can modify code, then most likely they are using maybe one of the two tools that I mentioned here at the end. But in essence, I guess, if that's the case, well, of course, the major difference with the Kotlin compiler plugin is that it should work for other platforms as well, not only Java.
Another question from Tristan: does Arrow Meta have ways to integrate with the IDE to indicate where code will be generated?
It does.
Okay, nice.
Yeah, actually, Arrow Meta does a lot more things than the ones that I show here. I really recommend you to go take a look at their website. They do other couple of cool stuff, and one of those is to integrate with the IDE itself.
Cool. So yeah, if there's any other questions, to jump in. One question I had was, so one of the cool examples I've seen is the of a Kotlin compiler plugin is the no copy one. So it'll, from your data classes, it'll remove the copy constructor if you want to have a private constructor and not expose that. Do you know of any other Kotlin compiler plugins that are like any use cases?
Yeah, as I was mentioning, the Parcelize tool, it's also a compiler plugin. Also there's one called NoArgs, which creates a NoArg constructor, which is needed for some tools. Android Kotlin extensions.
And are they written with Arrow Meta or the other way?
No, they are official from the guys on IntelliJ itself.
Oh, okay. Yeah.
So they have, yeah, I forgot to share here. I might share it in the group later. They have a folder where you can see all of the plugins that are created by IntelliJ, that or the Kotlin compiler plugin. There's a bunch of them there.
Okay, awesome. Yeah, thanks very much, Cesar. That was really great.
Thank you.
And yeah, we can talk about. I saw Tristan, you shared your links and resources in the Dublin Slack channel and the Kotlin Lang Slack show. So maybe we can share some stuff there, and we'll also post some links on the Meetup page. Cool.
Cool. Thank you.
All right. Thanks very much, everyone. We'll wrap it up there. See you.
Thanks.